Good morning, friends. So in the previous lecture we were solving about the sums related to the nth term of an arithmetic progression, right? Let us quickly recall the formula to find out the nth term of an arithmetic progression, that is given by an equals to a plus n minus 1 into d, where an is the nth term, or you can also call it as the last term of the AP. A, that is the first term of the AP, and D is the common difference of the AP. So we were talking about this nth term of an arithmetic progression given by an equals to a plus n minus 1 into d. Now here we are going to continue with the sums that we were solving here, right? So the question that has been with me is check whether, I think we were solving the 10th sum, check whether minus 150 is a term of the AP. Now the AP given here is 11, 8, 5, 2 and so on, right? Check whether minus 150 is a term of the arithmetic progression given to you is or not. So let us check how to solve here. The given AP. What is the AP given as? 11, 8, 5, 2 and so on. So from this AP we can get the first term, that is 11. We can get the common difference, that is 8 minus 11, that is minus 3. And we are having a term that we need to check for minus 150 or not. So whether this lies in this AP or not, for that we shall take an equals to minus 150, for which we will require the value of n. Now friends, again let us discuss that the value of n here must belong to the natural number, right? That means the value of n, whatever we get here, must be a natural number. So using the formula an equals to a plus n minus 1 into d, that is minus 150 equals to a, that is 11 plus n minus 1 into minus 3. Let us solve this. Therefore minus 150 equals to 11 minus 3n minus minus plus 3. Therefore minus 150 equals to 14 minus 3n, right? Let us take 150 on the other side and 3n here. Therefore this gives me 3n equals to 14 plus 150. 14 plus 150, that is 164. Therefore let me solve it here. Therefore 3n equals to 164, and hence n equals to 164 upon 3, which does not belong to a natural number, because you cannot cancel out 164 by 3. That is not possible, I think, right? That will give you 54 point something 22, that is 54.66, right? So if you divide this number, that will become a decimal number, because here this is a rational number, and division of rational number here will be either terminating decimal or non-terminating decimal or non-terminating non-repeating decimal, right? So you can get either of these three. So this will be a decimal number, it will be a non-terminating decimal number, so that does not belong to natural number. Hence therefore minus 150 is not a term of the given AP, right? So we can come to a conclusion that minus 150 is not a term of the given arithmetic progression. Is it clear? Okay. Now we shall solve some more sums related to the same topic. I'm having one more question here with me, that find the 31st term. Find the 31st term of an AP whose 11th term is 38 and 16th term is 73. So we need to find out the 31st term of the AP. Friends, we don't need to find out the arithmetic progression here. See, right? We just need the 31st term of the arithmetic progression, and that can be obtained again by using the same formula that we used to write down here, that we have written here in the first place. So let us discuss here. Given that 11th term is 38, therefore A11 equals to 38, it is given, right? And comparing this A11 with the standard form, the general form of the arithmetic progression, we shall get that term of the general form as A plus 10D. Therefore A plus 10D is equals to 38. This is my first equation, right? Similarly, we are also given the 16th term, and 16th term is 73, right? Therefore A16 equals to 73. Therefore we can say that again from the general form we are having A plus 15D is equals to 73, right? So we got two equations which we can say that they are the linear pair of equations in two variables. So we can solve them, right? Subtracting or eliminate equations 1 and equation 2, right? If we eliminate 1 and 2, what are we going to get is A plus 15D is equals to 73 and A plus 10D is equals to 38. So subtracting them, A and A will be cancelled. 15D minus 10D, that is 5D, is equals to 73 minus 38, that is I think 35. If you clearly see, that is 35, and hence D is equals to 7, right? So we got the value of the difference, the common difference, that is 7 here. Okay. Now friends, finding out the value of A, because as we require the 31st term, so comparing that with the general form, we must get the value of A and D. Therefore substitute the value of, or D is equals to 7 in equation number either 1 or either 2. Let us substitute it in 1. So 1, we get A plus 10 into 7 is equals to 38. Therefore A plus 70 is equals to 38, and hence we get the value of A, that is 32, right? That will be 32. So the first term here, A, is 32, and sorry, I think I might have made some mistake. we are not getting the perfect because that will become minus here, and so a plus 15d is 73. Did I make any mistake here in writing down the question? No. D is equals to 7, that is 70. Okay, that is minus 32, friends. So there was no mistake. A plus 10 into 7 is equals to 38. Therefore, A plus 70 is equals to 38, and hence A is equals to minus 32. That was the only mistake. I just forgot that minus sign. So that is A equals to minus 32. Now, the 31st term of the AP is A31, that is equals to A plus 30D, right? This A plus 30D, that we got it from the general form of the arithmetic progression. So A plus 30D, we are having A and we are also having D. So let us simply replace it here. That is minus 32 plus 30 into 7, that is minus 32 plus 210, right? We need to add this both, that is 210 and 32 must be subtracted from this, so that we will get 178, I think, right? And that is equals to 178. So the 31st term of the arithmetic progression so formed by these two conditions, that is if the 11th term of the arithmetic progression is 38 and if the 16th term is 73, then the 31st term of the same arithmetic progression will be 178. Is it clear, friends? So in this way we can find out the number of term that is given to, that is asked to us without finding the arithmetic progression. Okay, friends? Now we are going to move on to the next sums. Let me erase this. Now the next kind of sum here with me is, that is somewhat a tricky one, right? That was the 10th, 11th, and now we are going to move with the 12th sum. An AP consists of, an AP consists of 50 terms, of which the third term is 12 and the last term is 106. Find its 29th term, right? So again, see friends, that here we are having an arithmetic progression which consists of 50 terms, and the third term of the arithmetic progression is 12 and the last term, friends, see here it is not said that which term is 106, but it is indirectly said that the last term is 106. So the total number of terms present in the arithmetic progression right now is 50. Hence the 50th term will be the last term. So this is the trick, that the last term or the 50th term of the arithmetic progression is 106. Okay, friends, so you need to understand that the last term is actually the 50th term. Now let us solve this here. Given that third term is equals to 12. Therefore, A3 equals to 12. Comparing with the general form, A plus 2D is equals to 12. So we got the first equation here, A plus 2D equals to 12. And the last term, or the 50th term, for your understanding I am writing it here, is equals to 106. Therefore, A50 is equals to 106, that is A plus 49D is equals to 106. So we got the second equation also, right? Now let us eliminate them. Eliminate equations 1 and equations 2. So we get that A plus 49D is equals to 106 and A plus 2D is equals to 12. So subtracting them, A and A will be cancelled. 49 minus 2, that is 47D is equals to 94. Hence D is equals to 2. So we got the value of D as 2, right? Here D is equals to 2. Now for finding out the 29th term, we will also require the first term. Substitute D is equals to 2 in equation 1. We get A plus 2 into 2 is equals to 12. Therefore, A plus 8 is equals to 12, which will give me A equals, 2 into 2 is 4, my mistake. That is A is equals to 8, right? So we got the value of A as 8, and hence now we can get the 29th term. Yes or no? No. Therefore, the 29th term of the AP is A29, that is equals to A plus 28D, which is 8 plus 28 into 2. 28 into 2 is 56. 56 plus 8, that is 64. That is A29 is equals to 64, right? So the 29th term of the given arithmetic progression of, or the AP, that is consisting of 50 terms, is the value 64. Is it clear to you, friends? Right? So that is now the kind of sum that we were talking about. Again, one more I am having of somewhat of a different kind that might trick you, that for an AP, the third term and the ninth terms are 4 and minus 8 respectively. Which term of this AP is 0? So friends, again see here that in this kind of questions there is no AP given, but we are given two references, that is the third term and the ninth terms are 4 and minus 8. Now we need to check whether which term of the arithmetic progression that is talking here about is 0, right? So here the third term is equals to 4. See friends, first we are talking about the third term. So the first number that will be related to the third term and the ninth terms or the ninth term is the second number, right? So first to first and second to second, because it is said that they are respectively, that means with respect to. The first is with respect to the first number, the second condition is with respect to the second number. Okay, so you are going to look it like that. So here the third term is equals to 4 and ninth term is equals to -8. So to talk about these two, A3, therefore A3 is equals to 4 and A9 is equals to -8, right? What is A3 when compared to the general form of the AP? A plus 2D, therefore A plus 2D equals to 4, that is my first equation, and A9, that is A plus 8D equals to -8, that is my second equation. So this both the equations are here with us now. So we can eliminate them to solve this both. Therefore, eliminating 1 and 2, what do we get is A plus 8D equals to -8 and A plus 2D is equals to 4, right? Is equal to 4. So subtracting them, we shall get 6D equals to -12 and hence D is equals to -2, right? We shall get D is equals to -2 and 6D equals to -12 and D equals to -2. Substituting this, D equals to -2, substitute D equals to -2 in equation number 1, we get, what do we get? That is A plus 2 into -2, that is equals to 4. That is A minus 4 equals to 4 and hence A is equals to 8. Right? So we got A equals to 8. Is it clear, friends? So we got the values of A and D, but we don't require this. We need to find out that which term of the AP is 0. Now, to find which term of the AP is 0, let AN is equal to 0. So for this AN equals to 0, we will find out the value of N, right? For this AN equals to 0, we will find out the value of N. Therefore, A plus N minus 1 into D is equal to 0, right? Because that is the formula of AN. Putting down the values of A and D, therefore 8 plus N minus 1 into -2 equal to 0. Therefore 8 minus 2n plus 2 is equal to 0. Taking that 2n on the other side, therefore 2n equals to 10, which gives me n equals to 5. Is it clear, friends? So the value of n, or the fifth term of the arithmetic progression so formed, is 0. Which term? So the fifth term. Therefore the fifth term of the AP is 0, right? The answer to the question, which term is 0? So the fifth term of the AP is 0. So in this way you can find out the number of term for which it is the required value. Here we are knowing, here we are needed to find out that which term is 0. So the fifth term is 0. If it is asked that which term is -12, so we can also find out that number of term for which AN is equals to -12. Okay. Okay. Now friends, let us solve the sum that is one of a kind here, and that is the most easiest one according to me. The 17th term of an AP exceeds its 10th term by 7. Find the common difference. Find the common difference. So we need to find out the common difference for which common difference of the AP for which the 17th term exceeds its 10th term by 7. So friends, you clearly need to understand here that which term exceeds. Exceeds simply means it is more than the remaining or more than the other one, right? So exceeds simply means more than, right? Now which term exceeds? So we can say that 17th term. Now understand or listen as I speak. The 17th term of an AP is more than the 10th term by 7, or it is 7 more than the 10th term, right? We shall simply change the statement that the 17th term of an AP is 7 more than the 10th term, right? So according to the condition given here, according to the given condition, we can write down that A17 is equals to A10 plus 7. Yes or no? A17 is equals to A10 plus 7. Now understand, the 17th term, that is A17, exceeds that is more than, right? Exceeds the 10th term by 7. That means it is, or the 17th term is 7 more than the 10th term. 7 more than, that means plus 7. The 10th term, that is A10. If I say that marks obtained by Ram is 10 more than marks obtained by Shyam, so first of all we shall take the reference of Shyam, right? So marks obtained by Shyam, let the marks obtained be 25. Then what will be the marks obtained by Ram? 10 plus 25, that is 35. The same condition is being put here, that the 17th term exceeds the 10th term by 7. So according to the general form of the arithmetic progressions, what is A17? That is A plus 16D is equals to A10, that is A plus 9D plus 7. So you can cancel out A and A on both the sides. Therefore 16D minus this 9D here will be taken on the left side, that will become minus, is equals to 7. Therefore 7D is equals to 7, and hence D is equals to 1. So there is no need to do anything here. We can directly get the common difference when this kind of question is being asked. Is it clear? So the difference, the common difference for the given arithmetic progression is 1. Okay friends, right? Now next we shall solve some of the sums. Now I am having one more sum here, is related to the multiples, right? Related to the multiples. Before that, let us solve one or two of the same kind that we have solved here, exceeds and more than and less than type. Then we shall move on to that. multiples. So the next question here is 14th one. Which term of the AP is given to me, that is 3, 15, 27, 39 and so on, is or will be 132 more than its 54th term, right? So again, understand the question, friends, that which term of the AP that is given to us here is 132 more than its 54th term. So we are looking for that value of n. What we are looking for is that value of n, which term, so that relates to the value of n, and that n is 132 more than its 54th term. So here the given AP is 3, 15, 27, 39 and so on, right? So we are given this AP, therefore the first term, that is 3, the common difference, that is 12, right? 15 minus 3, 12, 27 minus 15 is 12. So we got this A and D from this arithmetic progression given. Now according to and let the nth term is equals to an, right? Let the nth term be an, so that we need to find out which term we have assumed that is an. Now according to the condition, what is the condition given to us here is which term, that means an, is 132 more than his 54th term. Therefore an is equals to a54 plus 132. Can I write it like this, right? Let us say that the required term is an, so an equals to 132 more, that means plus 132, but plus 132 is to be added to this 54th term, which is a54. Is it clear, friends? So that is how the condition goes. Now let us find out the value of n here. Putting the values here or putting the formulas here, that gives me a plus n minus 1 into d, that is a plus 53d plus 132. So you can simply cancel out this a and a, putting down the values of d here. Therefore n minus 1 into 12 is equals to 53 into 12 plus 132, right? So 53 into 12, what is 53 into 12? Multiply it and you can get the answer, that is 636, right? And here you can also get, that is 12n minus 12, that is 636 plus 132, right? 636 plus 132, that is 768. Therefore 12n is equals to 768 plus 12, right? And we can add that 12n is equals to 780. Yes or no? Okay. Therefore n is equals to 780 upon 12, that is 65. Hence n is equals to 65, right? Therefore the required term is the 65th term. right? Or you can also say that 65th term of the given arithmetic progression is 132 more than its 54th term. 65th term of the given AP is 132 more than its 54th term. Is it clear, friends? So that is the n that we were looking for, that is the term that we were looking for, that is the 65th term. Is it clear, everyone? Okay, good. Now we shall move on to the next kind of sum, that is, I am having a question here that is related to the multiples now. How many two-digit numbers are divisible by 3? How many two-digit numbers are divisible by 3? We need to look for this question, right? So for solving this question, first of all, what do we require is the list of two-digit numbers. Actually, the list of two-digit numbers starts from 10. Yes or no? Right? The list of two-digit numbers starts from 10. So here we only require the two-digit numbers divisible by 3, right? We only require the two-digit numbers divisible by 3. To find out this two-digit numbers divisible by 3, first of all we must know that what are the two-digit numbers up to 99 starting from 10. See, friends, you cannot write down 1 as 01 and call it as a two-digit number, because 01 does not make any sense as a two-digit number, right? So you cannot write down from 1 to 9 as any of the two-digit numbers. So the first valid legal two-digit number is 10 and the last valid legal two-digit number is 99. Now we only require the numbers that are divisible by 3. So to find out this, we can simply check whether which of the numbers are perfectly divided by 3. Perfectly divided by 3, that means which of the numbers are divided by 3 leaving 0 as a remainder, right? Leaving 0 as a remainder. So here 10 cannot be divided by 3 because that will leave me 1 as a remainder. Same as that for the 11. 11 cannot be divided by 3 because that will give me 2 as a remainder. 12, if I divide 12 by 3, that will give me 0 as a remainder because the quotient there becomes 4. That is 3 into 4 is 12. So the first number here will be 12. Now simply, rather than dividing each and every number, once if we get the first number, simply add 3 to each and every preceding number so as to get the succeeding numbers, because each and every number that we must get here is divisible by 3. That means that will be in difference of 3, right? This trick is applicable to those questions where if it is asked to find out the two-digit numbers divisible by 7, then again you can also apply that the first number divisible by 7 is 14. In the same way you can go for the next one, 14 plus 7 21 plus 7 28 plus 7 35 and so on. Okay, friends, so that is the first number. Here we only require the two-digit numbers divisible by 3, which are 12, 15, 18 up to 99. See, friends, the number 99 itself is divisible by 3. You can get 33 as the quotient and 0 as the remainder. So we got the AP here, that is 12, 15, 18 up to 99. Therefore, the first term for the AP is 12. The difference obviously is 3. and here we can get L as 99, right? L as 99, and we also know that L is equals to our AN, right? So in place of L we can use now AN. So we can directly write down that AN is equals to 99, for which we have to find out the value of N, right? For which we have to find out the value of N. Okay, so here now using the formula, therefore using the formula AN, A plus N minus 1 into D, right? Therefore putting the values, 99 is equals to A, that is 12 plus N minus 1 into 3. Solving this, we get 99 is equals to 12 plus 3n minus 3, right? What is that equals to? 99 equals to 12 minus 3, that is 9 plus 3n. Therefore 90 is equals to 3n, and hence n is equals to 30, right? Hence n is equals to 30. So friends, we can say that for n equals to 30, that means there are 30 two-digit numbers. Therefore there are 30 two-digit numbers divisible by 3, right? How many two-digit numbers are there? 30, which are divisible by 3. Is it clear? So this is how we can find out that how many two-digit numbers are divisible by 3, or how many of the terms are divisible by 3, right? One of the same kind I am having here with me is how many three-digit numbers are divisible by 7. So I need to erase this. Okay, let us try to solve it here itself. 16th one, how many three-digit numbers are divisible by 7, right? So if I require more space, then I am going to erase this one here so that I can write it down the continuation part here. Okay. Now how many three-digit numbers are divisible by 7? So first of all, we must have the list of these three-digit numbers that are available to us, right? So the list of those three-digit numbers that are available to us is, right, starting from 100 to 999. Is it clear? So the three-digit numbers, the list of those three-digit numbers that are available to us right now is starting from 100 to 999. But we don't know that which of these numbers right now are divisible by 7. But we can find it out. Okay? How to find out those? As we discussed here, that simply find out those numbers by dividing. How? Let us check it for this. If I am having this 100, let me write down 100, 101, 102, 103, 104, 105. Similarly, so on up to 999. Check whether 100 is divisible by 7 or not. So if I divide this by 7, I shall get 7 into 1, 7, and 30, 7 into 4, 28. So this will give me 2 as remainder. If I divide 101 by 7, this will give me 3 as remainder. This will give me 4, this will give me 5, this will give me 6, and this will give me 0. See friends, this will not give me 7 as remainder because that 7 remainder is divided by the divisor 7. Okay, so that we get 0 as the remainder. So we got our first term which is divisible by 7, right? So here we only require the numbers divisible by 7, which are 105. Now the second number, as I said, we simply are going to add 7 to this number so that we get the next number, that is 112. Then again adding 7, that will become 119 up to. But as we are bounded to the 3-digit numbers, that as we know the last number is 999, so we again shall find out the last number as we found out in the previous example. So the last number here is 999, divide that by 7. So what I am going to get is 7 into 1, 7, remainder 2, 29, 7 into 4, 28, remainder 1, 19, that is 7 into 2, 14, right? 7 into 2 is 14. So this will give me 5 as remainder. Now again we shall go further, that means we are now going to get 998, 997, 996, 995, 994, and so on, right? So here if it is 5, then here it must be 4, 3, 2, 1, and the remainder here must be 0. Friends, try it by yourself, right? Try it by yourself. See, here the remainders were in increasing order, now here they will be in the decreasing order, right? Because the numbers are decreasing. In the first case they were increasing, in the second case they are decreasing. Here see friends, 100, 101, 102 and up to 105, the numbers were increasing, so the remainders are also going to increase. You can check it by yourself, right? You can check it by yourself. Similarly here in the second case the numbers are decreasing, that is 999, 998, 997 up to 994. So when we divide these all numbers by 7, we can get these numbers 5, 4, 3, 2, 1, 0 as the respective remainders. So the last number, that will be 994, right? We have already solved, or I have already solved this question by myself, so I know that which numbers here will be last, right? You need to check it simply by dividing, right? You can simply get these results by dividing the numbers such that they will form an AP here, right? Okay, so we got the AP here, that is 105, 112, 119 and up to 94. Therefore A is equals to 105, D is equals to 7, that is obvious, and AN equals to 994, for which we are going to find out the value of N. Is it clear? Right? AN equals to 994, for which we are going to find out the value of N. Therefore, using the formula, AN is equals to A plus N minus 1 into D. Therefore, 994 equals to 105 plus N minus 1 into 7. So let us solve this. Therefore 994 equals to 105 plus 7n minus 7. Therefore 994 equals to 98 plus 7n, which will give me, therefore 7n equals to 994 minus 98, therefore 7n is equals to 896 and n is equals to 896 upon 7. So that is 7 into 1, 7, 19, 7 into 2, 14 and 7 into 8, 56. Therefore n is equals to 128. So there are 128 such numbers which are divisible by 7. Therefore there are 128 numbers divisible by 7. 128 3-digit numbers. Right? 128 3-digit numbers divisible by 7. Is it clear, friends? Right? So in this way we can solve how these kind of multiples are being divisible by 3 or 7 or anything. Okay? Now we shall solve one more, that is quite an important one for me. The question goes like, find the 11th term from the last of the AP. 17th question actually. Find the 11th term from the last of the AP. From the last, that means from the last towards the first, right? From the last towards the first of the AP. 10, 7, 4 up to minus 62, right? Up to minus 62. So that is the AP given to us, and we need to find out the 11th term from the last. That means from the minus 62, which is the 11th term. So here given AP, that is 10, 7, 4 up to minus 62, right? And to find out the 11th term from the last, first of all let us find out the total number of terms here. So we have A equals to 10, D equals to minus 3, AN equals to minus 62, for which we shall find out the n. Friends, don't take this n as 11, because we are not having the 11th term that is from the first, we are having it from the last. Here this 11th term is from the last, and this n that we get here, or the nth term that we get here, is from the first. Therefore using the formula AN is equals to A plus n minus 1 into D, that is minus 62 is equals to 10 plus n minus 1 into minus 3. Therefore minus 62 is equals to 10 minus 3n plus 3. Therefore minus 62 is equals to 13 minus 3n. Therefore 3n is equals to 62 plus 13, which is equals to 75. Therefore n is equals to 3n, and hence n is equals to 25. So there are total 25 terms here right now. This 10, 7, 4 up to minus 62, that gives me how many terms? 25 terms. Okay, is it clear? So that is n equals to 25. Now to find out, to find the 11th term from last, n equals to, or new n, let us write down new n, that is equals to total terms minus required term plus 1. See friends how it goes. Total terms, what is total terms? 29 minus required term. Now we shall take that required term as 11. So to find out the 11th term from the last, this capital N here simply means required term from the first. From the first, that means from the given AP in the sequence. So which term is the 11th term from the last? Which term is the 11th term from the last? For that we shall get n, that is total terms minus required terms plus 1. So total terms are 25 minus required terms is 11 plus 1, that is 14 plus 1, which is equals to 15th term. Right? Now we got n equals to 15 and we shall find out the 15th term from the first. Therefore again using n equals to a plus n minus 1 into d, this implies a15 is equals to 10 plus 15 minus 1 into minus 3, that is 10 plus 14 into minus 3. 14 into minus 3 is 42, that is equals to 10 minus 42, that is a15 equals to minus 32. Right? So the 11th term from the last or the 15th term from the first, both will be same. Therefore the 11th term from the last is minus 32. Is it clear friends? Right, the 11th term from the last is minus 32. So that is how we can find out the number of terms from the last or number of terms from the first as and when required. Is it clear? So I think you must note this down so that we can solve the next, that is the same kind of the sum. Sorry. Done? Okay, so let me erase this all. Okay, now I'm having one more of the same kind, that is find the 20th term from the last. So the previous was 17th one. Find the 20th term from the last term of the AP 3, 8, 13 up to 253. Right? So that is the AP given to us, 3, 8, 13 up to 253, and we need to find out the 20th term from the last. So again here the AP given is 3, 8, 13 up to 253. Okay, therefore A is equals to 3, D is equals to 5, AN is equals to 253, for which we shall find out the value of N. Okay, therefore using the formula AN is equals to A plus N minus 1 into D, therefore 253 is equals to 3 plus N minus 1 into 5, therefore 253 is equals to 3 plus 5N minus 5, right? Therefore 253 is equals to 5N minus 2, therefore 5N is equals to 255, and hence N is equals to 51, right? N is equals to 51. So we got the total number of terms as 51. Now the 20th term from last is equals to, or is N equals to total terms minus required term plus 1th term from first plus 1th term from first from last term is this, right? That is equals to 51 minus 20 plus 1, that is 31 plus 1, which is equals to 32nd term. Yes or no? Right? So the 51st term from the last, sorry, the 20th term from the last is the 32nd term from first. So we got this N as 32, right? N as 32. Now we require this term, so we shall apply again the formula. Therefore again using AN equals to A plus N minus 1 into D, that is 3 plus 32 minus 1 into 5, that is equals to 3 plus 31 into 5, which is equals to 3 plus 155, which is equals to 158. So we got the 20th term from the end as 158. Okay friends, we got it as 158. Now if I want to find out this 158, this answer we got in a different manner, not like this. So what we are going to do is, we are going to simply reverse the AP, right? So we shall find out using the second method. Second method to this sum, right? What we shall do is, we shall simply reverse the AP. Reversing the AP will not reverse the order, actually the order will remain same, but what the thing happens is, the difference, the common difference is being reversed. So here the common difference was 5, now the common difference will become minus 5. So after reversing the AP, we get 253, 250 and so on up to 13, 8 and 3, right? See friends, what we did is, we simply reversed the AP, right? We didn't do anything new, we simply reversed the AP. That means the first term is now your last term and the last term is now your first term. So as we required the 20th term from the last will be now the 20th term from the first. Therefore the required term is now the 20th term of the AP, right? Therefore from the AP we get A equals to 253, D equals to 253 and 248, it will be minus 5, and what we are having is AN, that is equals to 3, right? AN is 3, we don't require anything, but we rather than require the N, and that is equals to 20 now. Therefore A20 or AN is equals to A plus N minus 1 into D. Therefore A20 is equals to 253 plus 20 minus 1 into minus 5, that is 253 plus 19 into minus 5. 19 into minus 5 is 95, yes or no? Yes. So that is 253 minus 95, and that is equals to 158, right? So again you got the same answer, that is 158. See friends, this 158 is the 20th term from the last for the given AP, is also the 20th term from the first if we reverse the AP. So that is the second method that is also applicable, and that is the first method that is also applicable. So you can use any of these methods to solve this sum. Rather than doing the second method, you can also solve it by first method if you know it, right? But you need to understand this much, that how to convert the last term to the first term, and here you need to simply reverse the order of the AP and then simply find out using the formula AN equals to A plus N minus 1 into D. Is it clear, friends? So I think most of the practice related to this chapter is being done here. Now in this chapter let us solve one or two more of the same kind of sums, and then we shall move on to the next topic, that is the sum of n terms of an arithmetic progression. Okay, let me write down the 19th question here. The question is, how many multiples of 4 lie between 10 and 250. So lie in between 10 and 250 is given, right? So the bounding of our numbers, list of numbers, is between 10 and 250, and we only require the multiples of 4. Multiples of 4 simply means those numbers which are perfectly divisible by 4, or those numbers which can be divided by 4 leaving a remainder 0. So here the multiples of 4 between 10 and 250 are, see friends, it is asked between 10 and 250, so you cannot take this 10 and 250 both. The numbers that you are going to take must be in between 10 and 250 only, except the boundaries are 12, 16, 20 up to 248, right? Simply you can check it by yourself. There is no need to prove here that y12, y16, y20 and y248. So we can get the AP, right? Therefore A is equals to 12, D is equals to 4, AN is equals to 248, for which we need to find out the value of n. Therefore, using an is equals to a plus n minus 1 into d, which is equals to 248 is equals to 12 plus n minus 1 into 4. Therefore, 248 is equals to 12 plus 4n minus 4. Therefore, 248 is equals to 8 plus 4n. Therefore, 240 is equals to 4n. Hence, n is equals to 60. Right? We got the value of n as 60. So, there are 60 multiples of 4 lying between 10 and 250. Right? How many multiples are there? There are 60 multiples of 4 lying in between 10 and 250. Is it clear? So that is the answer. Let us solve one more, the last one. You might be thinking that sir is solving one more, and they have reached up to the 20th sum. Right, friends? See, this is the practice that I am doing here. That is not for me. I know each and every sum that is being done here on the board, but I am solving it for you, that how to solve this kind of sums whenever they are asked in the examination. Okay? So the last one that we are going to solve here is, for what value of n? For what value, sorry, wait a minute. For what value of n are the nth terms of the two APs. The APs are given. The first one is 63, 65, 67 up to so on, and the second one is 3, 10, 17 up to so on, equal. For what value of n are the nth terms of the two APs equal? That means the nth term of both the APs here given are equal, but we need to find out that for what value of that n are these both equal. So let us try to solve this. Here, the given APs, the given APs are 63, 65, 67 up to so on. So this will give me A is equals to 63 and D is equals to 2 and 3, 10, 17 up to so on. So that will give me, let us make a difference here, that capital A is equals to 3 and capital D is equals to 7. Right? Because both the APs are different. First terms are different, common difference are also different, right? So let us make a difference here, that the first AP has small a as the first term and small d as the common difference, and the second AP has capital A as the first term and capital AD as the common difference. Now, as the nth term of both APs are same, that is AN is equals to AN, right? So as we have made a difference here, the nth term will also differ. So the nth term of the first AP is AN and nth term of the second AP is capital AN. That is equals to A plus n minus 1 into D is equals to A plus n minus 1 into D, right? Which is, putting down the values, 63 plus n minus 1 into 2 is equals to 3 plus n minus 1 into 7. First of all, let us solve it here itself. That is 63 plus 2n minus 2 is equals to 3 plus 7n minus 7. What is 63 minus 2? Therefore 61 plus 2n is equals to minus 4 plus 7n. Taking 2n on the other side and 4 here, that is 61 plus 4 is equals to 7n minus 2n, that is 65 is equals to 5n, and hence n is equals to 13, right? Therefore the 13th term of both APs are equal. Which term? The 13th term of both the APs are equal, right? So in this way you can find out how to get the common value of n for two different APs given to you. Is it clear, friends? So that is the maximum type of sums that we have solved here related to the nth term of an arithmetic progression, right? To the nth term of an arithmetic progression related to the formula an equals to a plus n minus 1 into d. Now in the next topic or in the next lecture we are going to start with the topic that is Sn, or the sum of the first n terms of an arithmetic progression. Thank you.